6.1 law signs, what we should learn. We should learn how to use law signs to solve triangles and how to solve real life problems. And really what we're solving is oblique triangles. And that just means non-right angle triangles. We know how to solve right angle triangles. So SOHCAHTOA, a squared plus b squared c squared, but we're going to try to solve non-right angle triangles. And the way we do that, so law signs is one of the first ones we're going to do it. But first we need to know how to label a triangle. When you see capital letters, those are the angles. And when you see lowercase letters, those are the sides. And they go across from each other. Like here, angle A, across from its side A. Angle C, side C. So we have that going on. If we have an oblique triangle, a non-right angle triangle, we can solve it using law signs this way. It's the proportions. You can put A over sine of A, that equals B over sine of B, which equals C over sine of C. It also works if you flip it around. Sine of A over A equals sine of B over B, and so on. That's one method we have to solve triangles that are not right angles, that don't have right angles. Now the thing about law, there's actually a lot of cases. You could solve it one triangle. Sometimes there might be two triangles. Sometimes there's not a triangle at all. We'll talk about all that. Let's do our first example here. For a triangle in figure 6.3, we'll just draw it ourselves. So we're just gonna go, here's A, B, C, doesn't really matter. C is 102.3, B is 28.7, and lowercase b is 27.4. Find all remaining sides and angles. We want to find everything that's missing. First, you can find the missing angle right there. We want to use a calculator on these problems. I'll bring it out right now. You want to make sure you're in degrees, because you notice the angles are all in degrees. I didn't write it there, but there you go. Hit mode, make sure I'm in degrees. First thing I'm going to do is find out my missing angle A there. So I'm going to do 180. All triangles have 180. And we're going to subtract off 102.3 and 28.7. And we get 49. So this angle here is 49. Now, if I want to find one of these missing sides, this side here is A, this side here is C. I'm going to use the law signs to find those. The key thing about law signs is you need a pair or a set. I need both the angle and its side. We have that here. I have angle B with side B. That's going to be the thing I set up. We're going to do 27.4 over sine 28.7. And we're going to use that to find anything we want. Let's go with A first. We're going to put the side first, A on top, over the sine of the angle. So sine of 49. And then we just multiply both sides by sine of 49. These cancel out, and you get A equals, I'm going to put that all into our calculator. I got sine of 49 times 27.4 divided by sine of 28.7. And we get, I forgot, like I made a mistake. I forgot to close my sign. Very classic mistake. I thought I did. I got to close this parenthesis here. Second insert parenthesis. And now I should get a good answer. 43.06. We'll round it to 43. Put 43. That's that side there. I got side A. And I got to find side C. We're just going to do the exact same thing. We're going to go 27.4 over sine of 28.7. But now we're going to solve for C. C over sine of 102.3. Same thing. I just want to get C by itself. I could cross multiply, or you just multiply both sides by sine of this. Sine of 102.3. I'm going to put in our calculator again. And we get 55.7. Let's say, I'm going to round that. That one I'll just go 55.7. So there we go. That's how we use law signs to find the missing sides of a triangle and the missing angle of a triangle too. Next one, now we can do an application problem. A pole tilts towards the sun at 8-degree angle. So it shows right there. From the vertical, and it casts a 22-foot shadow. That's my 22-foot shadow. The angle elevation from the tip of the pole is 43. How tall is... Okay, the key here is like this angle there, from here to here, is 90 plus 8, 98. And what I really need to do, if I want to find out what A is, this is not a right triangle because there's a little bit more right there. I want to figure out what A is. 98 goes with B, nothing there. 43 goes with A, nothing there. 22, nothing here, but I actually could find this. That's going to be 180 minus 98 minus 43, which is 39. This is 39 degrees. And now we have a pair. We have angle C with side C. So we're going to set it up. 22 over sine of 39 equals, we want to find out what A is. A goes with 43. A over sine of 43. We're going to multiply both sides by sine of 43. And to spare you, I put it in off camera, 23.8. That's how tall the pole is. 23.8 feet. Now, the thing about law of signs I mentioned earlier, there's something called the ambiguous case. Sometimes when you do law of signs, depending on what information they give you, you can actually have no triangles, one triangle, or two triangles. There's a little formula here to figure out what the height is, and then you can use that to compare with one of your sides to tell if you have none, one, or two. But honestly, easiest way to do it is first solve like normal. Solve the triangle like normal. If you can't do it, you have 0 triangles. There's no triangle. Can't, none. If you can, 1 or 2. How do you figure out if it's 2? Assume there's 2. And the way you do that, the way you do triangle 2 is the first angle you find, let's say it's angle A is the first one you find, A prime is going to be 180 minus that angle you find. That's the first angle found. So when you have two triangles, you found this angle here, and you're going to try to figure out what this angle is. You do 180 minus that one. When there's two triangles, that's the way it works. You want to assume there's two. Whatever the first angle you found was, you can find A prime of that, you do 180 minus that. If you could solve, if you can solve, two triangles. If not, only one. So for me, that's always been the easiest way. Always assume you always have two triangles. Solve like normal. If you're trying to solve like normal and you can't solve it, there's no triangle. If you can, then it's one or two. If you're solving it, after you find your first angle, do 180 minus that angle, and that's your first angle in triangle 2. If you could solve that triangle, then there's two triangles. If you can't, you'll learn real quickly, oh yeah, I can't solve this triangle. Then there's only one triangle. That's the process. Let's do this first one here. Who wants to solve this guy? Put a little triangle here, ABC. A is 22, angle A is 42, and B is 12. We're going to solve this triangle. I have a pair right here, pair of A. First thing we're going to do is find our angle B. We're going to set it up. We're going to do 22 over sine of 42 equals 12 over sine of B. So this one we cross multiply. 22 sine of B equals 12 sine of 42 divided by 22. Sine of B, we're going to put that all into our calculators. This time I will show you because it's a brand new operation. We're going to do 12 sine of 42. Don't forget to close parentheses, divided by 22. And we get 0.36498. Now I want angle B, not sine of angle B. The way to get rid of it, we're going to do sine inverse on both sides. Second sine inverse of our answer. I get 21.4, like that. So that's our angle up here, 21.4. Now we can use that to find our missing angle right here. If I want to find out what angle C is, I'm just going to do 180 minus those two. And we get 116.6. And now if I want to find out what angle C is, we're just going to do the same thing. We're going to do law of sines one more time. So we're going to do 22 over sine of 42 equals C over sine of 116.6. Get rid of the sine of 116, we multiply both sides by it. And we get 29.4 equals C. We've solved that triangle. Now, normally when there's two triangles, we get our first angle and we go 180. B prime is equal 180 minus that triangle. This gives us 158.6. Basically, our triangle 2, exact same thing. We put all the stuff we start off with. A is 22. We have 42. We have 12. And then we just figured out angle B is 158.6. You notice something already? These two are way too big. That angle and that angle right there, that's already more than 180. So there's no two triangles, it's just one. That's what I mean. If they ask you, is there one or two triangles? Assume there's two. Get your first angle you find, do 180 minus that. If it works as a triangle, then you're done. Then you have two triangles. If it doesn't work, you'll find out right away. Like, oh, too big. These triangles are too big. It's just one triangle. Okay, no solution case. This one should not work out. Again, don't do anything special. Just try to solve it. Angle A is 85. Side A is 15. And side B is 25. We have a pair, we have the A's. We're going to do 15 over sine of A. And honestly, let's scratch that. Let's flip it upside down to make it a little easier. Because we're going to look for an angle. Whatever you're looking for, you want that to be on top. So we're going to do sine of A, sine of 85 over 15 equals sine of B over 25. Get rid of the 25, times both sides by 25. We're going to put that into our calculator. We'll figure out what sine of B equals. And that's going to be 1.66. Make sure my calculator here. And you should know already, if we want to solve for sine, we're going to sine inverse both sides. Sine inverse only works. Sine has to be between -1 and 1. This is going to be too big. This will show you. Second time, we're going to get an error here because sine's too big. Can't be bigger than 1. Error. No triangle. That's how it's a no triangle case. You try to solve it, it doesn't work, you're done. The two triangle case, this one when we solve the second triangle, it should work out. Let's draw a little triangle here, ABC. This is 12 and 20.5, 31. All we're going to do, let's break this in half. I might have to use both of them. Let's solve this triangle first. We're looking for this angle here. So I'm going to do sine on top. Over 12 equals sine of B over 31. I'll just skip down to sine of B equals 0.905. And then sine inverse both sides. And I get 64.8 equals B. That's over there. Oh, and then we could do the same thing as always. We want to find C. C is going to be 180 minus those two. which is 94.7. Now I can figure out what side C is. I'm just looking for the side. I'm going to put the sides on top. I'm going to do C over sine of 94.7 equal to 12 over sine of 20.5. Multiply both sides by this. And then we get C is equal to approximately 34.2. That's all the angles and all the sides that are missing. Now for triangle 2, keep in mind it's going to be the exact same setup, or the exact same given. This is still 20.5. This is still 12. This is still 31. But our B is going to be different, because the way you find your B on this side, put B prime. B prime is equal to 180 minus, it's always the first angle you find, 180 minus 64.8. Which gets me 115.2. That's what my B prime is. And then, well, if you look at it, 150.2 and 20.5 are not too big. I could actually make another triangle with this. So we're just going to do what we always do. The way you figure out C is equal to 180 minus those two. That gets me 44.3. And then we got to find the missing side for C the same way we always do. The law of sines. It's going to be C over sine of 44.3 equals to 12 over sine of 20.5. We're going to solve that. If you solve it, you get C equals 23.9. So there's all our stuff. That's how you do two triangles. You solve the first triangle like normal, and if you want the second triangle, you get the first angle you find. That's your new B. In this case, it's B. You do 180 minus that triangle. That's your angle. If you can make a triangle out of it based on the angles, then you have a second triangle. And you just have to solve that second triangle the same way. That's a two triangle case. Okay, let's talk about area of an oblique triangle. That's the area of a non-right triangle. Because the area of a right triangle we know. Area of a right triangle is 1/2 base times height. How do you do a non-right triangle? Well, we have this area formula. It's area equals 1/2 BC sine A, or all these other ones. 1/2 AB sine C is the one I'm probably most familiar with. All it really means is this. You need, let's say this is ABC. The formula is you need the two sides and the angle between. So in this case, this will be area equals 1/2 side C, side B, sine of A. It's all, the key thing is it's two sides and included angle. That's it. If you have two sides and included angle, the sides go first and then sine of the included angle. That's the area formula. There's three different ones, but it's just two sides and area in between. Let's do an example here. Our last one. Find the area of a triangle that having sides of length 90 and 52 and including angle 102. This really is information. One side's 90, one side's 52, and the angle between is 102. So if I want the area of this is the formula. 1/2 AB sine C. Remember, all it means is the two sides, which is 90 and 52, and then sine of the angle between. Do that, you get your area, 2288.9, and that's the lesson.